Hi, welcome to the Self-Driving Factory podcast from 3AG Systems. My name is Matthew Gears, and I'm also joined today by Andrew Layarda.
Good afternoon.
Every episode, we're going to delve into the world of analytics, data engineering, machine learning, artificial intelligence, IoT, and anything we think will contribute to the concept of the self-driving factory. Today, what we wanted to talk about was to actually review an article that we saw this week from Network World, which was titled, Why IoT-Enabled Predictive Maintenance Hasn't Taken Off. And so this article is actually a summary of a survey that was done by Bain, where they interviewed more than 600 high-tech executives. And they summarized that in an article called Beyond Proofs of Concept, Scaling the Industrial IoT. The title alone is a bit of a mouthful. I would have called it something a lot simpler. But, I guess that's what you do when you're a big consulting firm. Anyways, the gist of the article was this. So industrial leaders were given a similar survey back in 2016 where they were asked what they thought about predictive maintenance. And what was discovered in this year's survey was that leaders just were not as excited about predictive maintenance. And for those of you who don't know what predictive maintenance is, it's basically using analytics and building out data models that allow you to predict what a machine might be doing based on sensor data that you're collecting. So a very simple example of that might be that you have a vibration sensor, and if that vibration sensor goes beyond a certain level of vibration, you know that something might be wrong, and you'll take an action in advance of it going wrong. This is much different than, slightly different than the concept of other sort of maintenance approaches like preventative maintenance, where you on a regular schedule actually go out and make changes or improvements or fixes to machinery in advance of it actually breaking down. And then, of course, the traditional, the brute force approach is that you just run a machine until it breaks down. And so the idea with predictive maintenance, just to repeat, is that you can actually know in advance, based on analytics that you're doing with data, whether or not something is going to go wrong with the machine. So it is a bit surprising, you would think, that 4 years later people are not as excited about this particular concept. And what the report found was a couple of things. So first, they found that people generally felt that implementing predictive maintenance was harder than expected. And that secondly, deriving valuable insight from that data also turned out to be unexpectedly challenging. To each of these points, I guess I'd like to give my opinion or my take on it, which is, I guess I can summarize it up with just one word, duh.
That's awesome.
With that, Andrew, we've had lots of discussions with people before. We've even talked with people who are doing predictive maintenance pilots. How do you view what you're hearing from this particular survey?
Well, again, to your point about looking at the findings here, combining it to what we learned by working with some customers and their attempts in doing predictive maintenance, right? There's actually two big things that came up from here. One, to their point about how implementing it has been harder than expected. I think generally what happens is there's this initial excitement and hype on predictive maintenance, and there's these proof of concept projects where they'll provide a snapshot of the data, they feed it into an algorithm, and it gives them something awesome, right? And then reality sets in. If you look further into the article too, they did say that after the survey in 2016, they did another survey in 2018, and then one of the top concerns became how to deal with multiple data formats, right? Mm-hmm. That goes into the fact that great, you can do all these pilots, but if you don't have solid data engineering and data pipelines underneath it that can feed you updated data to kind of feed into this model that you've created, it's not going to do you much good, right? Because by the time you spend the effort to get the data to this model, it's already late, right? So
right, and I think as well, maybe there's a difference there. Like when you're doing a proof of concept, you can effectively run a science project, right?
Exactly.
You could have whatever format you want. The challenge is taking that and turning that into an industrial scale. And so, if you've got one science project here that's using a particular format, and then you've got another science project over here that's using another format, and they're not connected together, and then you want to be able to pull something that integrates both of the science projects, it becomes a lot of work. And ultimately, if you were doing it in that way, it would grow exponentially in terms of complexity, in my view.
Yeah, absolutely. Like without the foundational data engineering practices and implementation that can actually feed and collect all these data, sanitize it, put it in one place so it's ready to consume, then it becomes challenging, which kind of reflects in the 2018 survey here, right?
Now, just sort of to go a bit off to the side on that, for people who aren't as familiar with these data practices that you're describing, could you sort of summarize what that would look like to someone who isn't as experienced in this space?
Oh, absolutely. So it's think of it as putting in, if you put the analogies of buildings and houses, right? Data engineering really is laying out solid foundations and plumbing inside your organization, so that you're putting the automation, the pipelines, to be able to tap into the different systems that you have running in organization, right? Every single organization has, they have a finance system, they have operational systems, they have HR systems, right? These systems, have their own implementation, their own backend, and the good data engineering practices are all these methods and automation and pipelines that you put in place to go into these separate systems, collect the data automatically, being able to apply certain kind of cleanup rules and aggregation rules and rules on how the data from the different systems should be interacting, and then collect them on a centralized data warehouse that you can then do your analysis on.
Okay, cool.
Yeah. Now, I'll say that. So that was the first point. The second point was related to the fact that, predictive maintenance. Maintenance in general is just one factor in a complex system, in an operation of a mine or a manufacturing plant, right? Therefore, the focus of predictive maintenance, while it might give you insights on when certain things are about to break down, but it doesn't give you full insight into the whole system, right? What is the impact of this thing breaking down? What is the net effect of you being able to provide proactive maintenance on this particular element or this particular equipment in your entire system, right? We found in some of our cases where when you optimize for just one system, you make that one system to be 100%, you might actually create bottlenecks everywhere else in the system because you're just so targeted on just the one thing. So
I think as well, there's obviously like a cost associated with doing these things too. So it really comes down to trying to understand what the goal is. Like if the goal of predictive maintenance was to have 100% uptime on every single machine, then potentially to prevent each machine from breaking down 100% of the time, as long as you're going around and putting enough resources into making sure that each one of those machines is running, you'll achieve your goal. In fact, you probably don't even need to do sophisticated planning on it or sophisticated analysis. You just go out and send people out to do that. But the reality is that there's costs associated with that, and it might be that in some cases, certain machines you want to have up more than others. Some machines you might be okay with them breaking down more if there's limited resources, because they might not be a part of the critical path. And in that case, they're going to have a small overall impact on the overall throughput for the entire plant. And so I guess what I'm trying to say in this sort of roundabout way is that if you're just looking at one facet of one machine, like its uptime, you're missing out on the larger system that you're trying to optimize. And so if you're just trying to look at one machine against the entire plant, you're not necessarily going to be optimizing for the plant. And if you're looking at one aspect for one machine versus its entire set of parameters and contribution to the entire operation, you'll also be missing out.
Yeah, absolutely. I mean, as we've kind of determined and as we've kind of discovered, right, through our different projects, right, when you have equipment interacting with other equipments that can feed back to the same equipment and all these different things that are in a sequence, it becomes a complex system, right? And when you're just doing, like, to me, predictive maintenance by itself becomes a local optimization, right? Whether are you optimizing for components of the system or you're optimizing for the entire system, which goes to your point earlier about there's always cost or finite resources, right? There's only so many dollars you can put in a maintenance team running around fixing things, right? Somehow this reminds me of the whole Shakespeare, infinite typewriters and infinite number of monkeys. You'll get the works of Shakespeare, right? And we know it's not the case here.
Maybe if you had an infinite number of consultants.
No, possible. Hasn't been tested, I suppose.
Yeah. So is there anything else that you sort of caught your attention on this particular article?
Well, I think one of the things that there's only one final thing that he talked about. In the article, they talked about 5G connectivity, right? And again, I think it is part of the solution potentially, but 5G connectivity itself is not the silver bullet that would necessarily make this a lot more accessible or a lot more useful. But certainly, it's one component in the whole solution.
Yeah, I think the quote was, given the progress in sensor technology, 5G connectivity, and edge computing and edge analytics, and an estimated 20 billion connected devices by 2020, there's little doubt of the potential for the technology to vastly improve everything. To me, that kind of says, well, all the ingredients are there, so it'll all work out.
Yep.
Again, that's fantastic, except that if you're not looking at the data and understanding like how to properly structure that data, and then from there derive the insights on a systemic basis, right from the very beginning, you're probably not going to work, even if you had an infinite number of IoT sensors with an infinite number of 5G connections, right?
100%, right? Yeah, exactly. Like the collection, because this goes into the collection and storage of the data, right? Once it's stored, then you still have to do some analysis on it. Otherwise, it just it'll just be collecting dust in a corner of your data storage somewhere.
Fair enough.
Yeah.
Okay, cool. Well, I think we've beaten this article up enough. So it seems like a good place to wrap up. Thank you again for listening to the Self-Driving Factory podcast from 3AG Systems. Till next time.